The Lexical Tokenization engine is a modular system for decomposing input streams into normalized token sequences. The engine processes character data through a series of stateless transformation stages. Each stage operates on discrete units with predictable input and output characteristics. The system maintains no global state between tokenization cycles. Configuration parameters are established at initialization and remain constant throughout the lifetime of the engine instance. Input streams are accepted as sequences of UTF-8 encoded bytes. The engine normalizes, encoding through a single-pass validation layer prior to tokenization. Invalid byte sequences trigger an error callback with cursor position data. The validation layer performs no character transformation. It reports encoding errors through a standard error handler interface that the caller may implement or leave unregistered. Default behavior for unhandled errors is stream termination. The whitespace elimination stage removes sequences of consecutive whitespace characters. Whitespace categories are defined by Unicode property tables. Tab characters, space characters, line breaks, and carriage returns are all treated as distinct whitespace types. The stage preserves sequence length information through metadata markers. These markers indicate which regions were whitespace compressed but do not alter the output token stream itself. Delimiter recognition operates through a finite state automaton with branching paths for each recognized delimiter type. Single character delimiters such as periods, commas, and semicolons are handled through direct lookup tables. Multi-character delimiters are processed through sequential character matching with optional lookahead. The automaton state is reset after each delimiter emission. Unrecognized character sequences following a potential delimiter trigger backtracking to resume standard tokenization. Numeric token recognition applies to sequences composed entirely of digit characters and optional decimal separators. The decimal separator character is configurable and defaults to the period symbol. Tokens containing multiple decimal separators are rejected and returned as error tokens. Leading zeros are preserved in the output representation. Negative signs preceding digit sequences are recognized only when preceded by specific delimiter characters. Alphabetic token recognition handles sequences of letters, as determined by Unicode category tables. Case transformation is performed as a configurable post-processing step. The default behavior preserves original case. Normalization options include lowercase conversion, uppercase conversion, or title case conversion applied uniformly across all alphabetic tokens. Mixed case tokens remain intact when no normalization option is selected. The symbol categorization subsystem assigns semantic roles to non-alphanumeric characters. Mathematical operators, logical operators, and assignment operators receive distinct classification codes. Punctuation symbols receive a separate classification. Unknown symbols are assigned a generic symbol token type. Classification is deterministic and based solely on character identity. The classification table is immutable during engine operation. Token metadata collection occurs in parallel with token emission. Each token carries position information indicating its byte offset within the input stream. Line number tracking is maintained through carriage return and new line detection. Column offset is computed relative to the last detected line boundary. Metadata is attached to tokens during the emission phase and is immutable once assigned. The escape sequence processing layer handles \prefixed character sequences. Standard escape codes such as newline, tab, and quote characters are recognized and converted to their literal equivalents. Unrecognized escape sequences are preserved as two-character sequences with a \ maintained. Escape processing occurs prior to delimiter and alphabetic recognition. Escape delimiters are treated as alphabetic character data rather than structural elements. Quote-delimited token sequences are processed through a dedicated state machine. Opening quotes of supported types trigger quote mode activation. Quote mode remains active until a closing quote of matching type is encountered. Content between quotes is preserved verbatim without delimiter or escape processing. Unmatched quotes result in stream error conditions. Quote type is configurable with defaults supporting single and double quotes. Token deduplication is optional and disabled by default. When enabled, a lexicographic trie structure maintains references to previously emitted tokens. Subsequent identical tokens are referenced by pointer rather than duplicated. Memory usage reduction scales with token repetition frequency. Deduplication adds computational overhead during token emission proportional to the trie depth. The deduplication structure is cleared upon engine reset. Output buffering occurs through a ring buffer of fixed capacity. Token data is appended sequentially. Ring buffer wraparound occurs when the write position exceeds the configured buffer limit. Wraparound overwrites existing tokens beginning from the buffer start. The caller must drain buffered tokens prior to capacity saturation to avoid data loss. Current fill level is available through a query function. Error handling follows a callback-based model. Each error condition invokes a registered error handler function with error type and position metadata. Handler execution occurs synchronously within the tokenization call stack. Multiple errors may accumulate during a single tokenization cycle. Error handlers may log, filter, or terminate processing as required. Default handler behavior is to continue tokenization. The streaming mode interface accepts data incrementally through append operations. Partial tokens at the input boundary are buffered internally across append calls. Token emission occurs only when sufficient data is available to complete token parsing. End-of-stream signaling through an explicit flush operation forces completion of partial tokens. Partial tokens at stream termination trigger error callbacks. Configuration parameters are applied at engine construction and are immutable thereafter. Mutable settings are not supported. Parameter validation occurs during initialization. Invalid parameter combinations trigger initialization errors. Configuration includes whitespace handling policy, case transformation, delimiter set, quote type support, and buffer capacity. Default configurations are optimized for general-purpose text tokenization with standard ASCII delimiters. Engine lifecycle management provides construction, operation, and cleanup phases. Construction allocates internal buffers and initializes state structures. The operation phase processes tokenization requests. Cleanup phase releases allocated memory. Engines may be reused across multiple tokenization cycles without reconstruction. Reset operations clear internal state between cycles. Resource guarantees specify predictable memory allocation patterns and release timing.